Hey everyone, welcome back to my another YOLO tutorial. In this tutorial I will talk how to run YOLO on Raspberry Pi. So in this tutorial I will provide step-by-step instructions for how to set up TensorFlow 2 on the Raspberry Pi. By following this step-by-step guide, you will be able to use your Raspberry to perform object detection on live video feeds from Picamera or USB webcam. After this tutorial, of course, you will be able to combine this tutorial with my previous tutorials on how to train your own custom Yolo V3 object detector to identify specific objects. The whole tutorial will be divided into 7 parts. So the first one is to set up and update the Raspberry Pi. I'm not going to show you step by step everything here, but actually here is a few steps which I use to install the Raspberry OS to the SD card. So first you need to install a Raspberry Pi operating system image on SD card. So to do that, if you haven't done this before, it's recommended to use Raspberry Pi Imager. Here you can see it, Raspberry Pi Imager, and it's available for all operating systems: Linux, Mac, Windows, Chrome OS, or so on. So I'm on Linux. I use this on Linux, and here I'll show you how I do this. And it looks following while installing. As you can see, you can even choose to install it with online download, or you can do this with a pre-downloaded operating system. So I choose to install Raspberry Pi OS with desktop without additional programs, because it's not a problem for us to install it later. It's more difficult for us to remove them if we need additional space. So after installation, the first thing you should do is to make things easier for us. We need to set up local network and wireless connectivity and enable SSH. So actually, I will provide a link on my text version tutorial where I show you how to enable SSH on Raspberry Pi, and actually I can show this for you after I will connect to my VNC server. And also, as I said, you will need to set up your client to connect to Raspberry through SSH. All this information is given in the same link from webpage. And to show you the next tutorial steps, I will connect to my Raspberry Pi through real VNS viewer, and it's also available, as I know, for Windows, Mac, and so on. And of course, there is a lot of softwares which you can use as VNC viewer. So I will just connect, and here it is, my Raspberry Pi. And first step I did when I installed the OS, I simply enabled Wi-Fi, connected to it, and then I went to preference, Raspberry Pi configuration, and first thing is I go to interfaces, enable camera, SSH, VNC. This is 3 most needed parts for us. And then I went to display, and I need to choose another resolution, but it's fine for us, 720 and 480. So it's enabled. And actually what we need to do, I will show all the steps for you step by step, as I said. And first thing we need to do is sudo apt get update. And few of these steps might take a while, so I will try to edit this while recording, because I don't want to waste your time and my time showing these frames where it shows how the percent spin. So depending on how long it's been since you have updated your Pi, the upgrade could take anywhere between a minute and an hour. So next step is this upgrade. This will take more time than the update, so let's wait a little bit, and I'll increase the speed of this video in this part. So let me show you one thing before this finishes. I can show you one more thing. Let's open another terminal. And some of you ask me why it runs Python 3 when I type Python in the terminal. That's quite easy, and I will show you how I do this. This is available both on Raspberry or Linux, and if you are on Linux, open your bash src file. So I'll use nano and bash rc like that. It's a little slower because of this installation. Right now, scroll to the end and type alias python equal to python 3. Let's save it. Yes, okay. And right now, if we'll write Python, it should open us a Python 2. Okay, let's exit this. And right now we should write source and bash rc. And right now, if I'll write Python, it should open me Python 3, as you can see, and it's temporary. Not temporary, but this will be all the time until you remove this line from bash rc script. So I exit and I can close this. And let's wait for our upgrade to finish. Okay, close it. Let's wait. Also, I remembered that I can download my repository, GitHub repository for this while it's installing the updates. And I will go to my GitHub page. Here it is. This is my page. You should already know this. And here's the object tracking and so on. You also can try this. And I go to clone my repository. I will copy the link and I go to my Raspberry. And I just write git clone. Oh, sorry. I need to go to desktop, and here I write git clone, and I paste here the link. Okay, that will download our link. My internet is quite fast, so it shouldn't take a long. But I will finish this step before doing another steps. As you can see, receiving objects. And also, if you go to my link of GitHub, here is the weights I also need to download. So I will download Yolo V3 tiny weights. I'm copying this line and I'm going back to my Raspberry Pi, checking our files done. And when it finishes, I will also download my weights. So I right now cd TensorFlow repository, and here I passed wget command to simply download tiny weights for us while it's working. Okay, I'll come back later when our installation finishes. So as you can see, the upgrade finished, and now we'll move to the second step, where I'll install all the needed packages and libraries. So Raspberry OS ships with Python 3 as a default Python installation. So we need to complete the following steps to install pip for Python 3. So I'll use sudo apt install python 3 pip. And the command will also install all the dependencies required for building Python modules. And as you can see, it's already installed. So once the installation is complete, we can verify the installation by checking the pip version. So I'll write a pip3 version, and it should give me 18, as you can see. But okay, this is finished. But most of the time this command installs not the newest version, so we need to upgrade it with the following command. So I'll write pip3 install upgrade pip. And after this upgrade, before moving to another step, we should install all batch of packages with command I will issue right now. And this will take a while again, so you just copy and paste this to terminal for my text version tutorial. So I'm copying. There's a lot of sudo apt install packages, so I'll copy it from different place. And I simply, as you can see, and I simply click enter. And it right now will check a lot of packages to install. And this, when this finish, will be finished working on step 2, and we'll move to step 3. So it finished installing, and the third step, as I said, is install OpenCV. In all my projects, I prefer to use OpenCV because it's easier to work with and less error prone. The object detection scripts in this guide, GitHub repository also uses OpenCV, so we need to install OpenCV, as you understand. If you already tried to run pip3 install OpenCV Python, you already might face that this way it doesn't work on Raspberry Pi. The problem is because the current version of OpenCV is not compatible with Raspberry Pi. The current version is 4 point so on, I don't know. To get OpenCV working on the Raspberry Pi, also there is a quite few dependencies that need to be installed through the apt-get. If any of the following commands don't work, issue sudo apt-get update and then try again. So also, as before, I'm not typing everything with my hand in the keyboard. I'm copying it, and of course you should check my text version tutorial, but there is a lot of dependencies which should be installed actually. And before installing, I don't have, so it doesn't matter. So let's press enter, and again let's wait to finish. I forgot to add yes. So right now, if you already tried to install OpenCV, just run pip3 uninstall OpenCV Python. So, and now that we got all these installed packages, we can install OpenCV. So simply run pip3 install OpenCV Python, and right now we'll add a version, specific version we would like to install, 2.7, just like that. This should sort you out, and if you have any issues, just check what version of OpenCV are compatible with your Raspberry and or whatever you are using. So as you can see, it's downloading and installing collecting packages for OpenCV. Everything should be fine. NumPy is already installed. Successfully installed. So right now let's open our Python and let's check if we can import it. Import CV2. Yeah, there's no errors. It means that everything is working for us. That's nice. So let's leave, and we just finished our third step. Next step is to install the TensorFlow. Now that we have installed all the packages, we need to install the TensorFlow. If you already tried to issue a pip install TensorFlow, you saw that it tries to install TensorFlow 1 point, I don't know, whatever. Of course, I can issue this. And not to install it by default, I'll write 2 point whatever, doesn't matter, and it should give me some kind of error that you could not find a version that satisfies the requirements TensorFlow 2. And as you can see, the best it can say is 1.14, and it doesn't satisfy us. So I found a very nice tutorial on GitHub, which I can show you a link, and it's called a TensorFlow bin from Pinto 0309, and there we can find our solution to this problem. And here it gives very nice solutions and explains everything step by step. And we simply go to the end where is an example of Python 3.x plus TensorFlow version 2 series, and there is a lot of stuff needed to install, but we already installed this step and it's left only this. So I'll copy and I'll install one by one of them. Let's copy another one. Finished. Let's move again. Copy. Well, actually, I think we can change this sign to more. But actually, it's better to do as they say. Git past, install h5pi. And here we'll get on a file, and of course it would be better to move to our desktop. So I'll simply use cd desktop. On the desktop I'll write wget. It's something missing here. So let's see what I forgot. Okay, how to exit this? Okay, not found, and I'll paste the full path. As you can see, it's appeared on desktop. And right now we go to this line. We copy this, but this is not enough. We need to add an sh at the beginning. And now we paste this, and as you can see, it's working on this file. It's downloading. So this step is not necessary. We'll use it only if you already tried to install TensorFlow and you already have, for example, 1.14 version. So we are skipping this, and we are copying the last line where we use our wheel installation. So I use opacity here, and right now we should install the TensorFlow 2 to our Raspberry. So after installation, we can open our Python terminal. Alright, just Python. Let's import our TensorFlow and print its version. So it's a little slow right now. Oh damn it, I need to reboot Raspberry. So I'll write Python 3 right now, and later I will reboot this. So it's open it, and let's import TensorFlow STF, and now let's print a version it can see, and if we don't receive any errors while importing. Okay, it's imported, and let's print tf.version, and as you can see it's 2.2, and exactly what we wanted to get. So this means that we finished our fourth step. So up to this point, we have almost everything we need installed and working. Python, OpenCV, TensorFlow. Now we can download my GitHub repository, what we actually already did at the beginning, which we'll use for our real-time object detection with Yolo V3. I recommend navigating to desktop, stay as I did if you did this before, and there clone my repository. So you will have it on your desktop. So while we are doing this detection not with Raspberry Pi, we would install requirements from my file, but actually because here's our requirements, here it is, but not to mess with OpenCV and TensorFlow we just installed, we will do these steps manually, so we will skip OpenCV and TensorFlow too, and we will install all other packages. So actually I will open Mini-C, and I simply have a list here on my notepad file, which I'll copy here. So we'll install NumPy, SkyPy, VGet, Seaborn, TQDM, Pandas, AWSCLI, and URL lib3. And actually, again, we need to wait. So as you can see, it finished again installing all the things we need, and actually it still need one of it, and it should be quite fast. Because I'm using Raspberry Pi, it's quite weak to run original Yolo V3, so I used to use Yolo V3 Tiny in this tutorial. So as you can see, I downloaded this at the beginning of this whole installation stuff. So that's it for fifth part actually, and we can remove all these files we don't need, and we can move to our sixth part. So now everything is set up for performing object detection on the Pi. The Python script detects objects in lib feeds from a Picamera or USB webcam. Basically, the script sets path to the module and label the map, loads the module into memory, initializes the Picamera, and then begins performing object detection on each video frame from the Picamera. If you are using Picamera, make sure it's enabled in the Raspberry Pi configuration menu. Now rather than using the Raspberry Pi camera module, you can use our standard USB webcam to take pictures and videos on the Raspberry Pi. Because I have only a standard USB camera, of course, you know what I'll use. I use the standard camera. First, we need to install the FS webcam package. So I'll use a sudo apt-get install FS webcam. And I think now we need to test it under the command fs webcam followed by a file name, and the picture will be taken to use the webcam and save the file name specified. So I'll use it fs webcam and image JPEG. As you can see, it captured something. I'm not sure, even somewhere here around my camera is laying. And let's see what I have. Oh yeah, there is my another computer, laptop, and here is the flashlight, and there's of course a mouse. That's cool. Our webcam is working. I thought I will need a restart of this Pi, but it seems I don't need it. So this was the easiest way to test our webcam. If your image was created, this means that our camera is working and we can move to the next final step. Otherwise, try to debug your problem with Google Help. Now actually I will remove this, and I think I'll need to reboot the Raspberry before doing the detection. So I'll do a reboot. So now we are back and our Pi was rebooted, and of course we can open this folder. Now to run real-time object detection we need to change configurations of our project. So open Yolo V3 configs.py, this one file, and we'll change a few lines here. As I said, I will be using Yolo V3 tiny, so I'll write true instead of false where it's tiny, and here I'll write 320 instead of 416, because a smaller input image will give us more frames per second actually. That's it. We save this, we close it, and we can open, we go back and that we open detection demo file, and here is detect image. We comment this and we uncomment detect real time. This is the webcam input takes. This way our script will use webcam output to our model as input. And now we can open our terminal, and I navigate to desktop and TensorFlow. Let's see if our Python works. As you can see, I wrote Python, it opened at 3.7, and this is what I said at the beginning. So if we did everything correctly, so we can run a Python detection demo Pi. Python detection demo Pi, and it should start working. And here we should see the frames per second, and somewhere here we should see output as a detection. Keep in mind this will be quite slow because this is a Raspberry 3B and it is really slow, and I was not working on how to make it faster or so on. I believe there is some kind of solutions, but I didn't want to waste my time because I will move next to the Android, and maybe there I will do this optimization things for you. So here it is. I'll take my Picamera and we'll see what it detects. Actually, I'm holding it right now, and as you can see, it detects me, and that's sad, but there's only 1 frame per second. And as you can see, I'm right now talking to the microphone, and you can see my mouth moving and so on. It detects person. Let's take my cell phone for example. Let's see if it can detect. Here it comes. No, it's too far. Yeah, it's a little bit. It can detect, but this is because this is a tiny version of YOLO and so on, and I need to move a little back, I think, and so on. Bottle person and so on. But anyway, you can see it works and it detects, and actually there's no more of the stuff I can show you. My camera is moving around. I was holding it in my hand, and that's it. If you, as I said, if you did everything correctly, you should see the results on the Raspberry Pi window. If you want to see my results, check my YouTube tutorial and so on. So that's it for this tutorial, and if you plan to run this on the Pi for extended period of time, for example greater than 5-10 minutes, make sure that you have a heatsink installed on the Pi main CPU. All the processing causes the CPU to run hot without a heatsink. It will shut down due to high temperature quite soon. In this tutorial, I showed only how to run a detection on pre-trained code core classes, and to run this detection on your custom model, check my previous tutorials on GitHub and at the end of the README file. Thanks for following through this tutorial. I hope this found useful for you. Good luck with your object detection application on the Raspberry Pi or whatever you're using, and see you in the next part. Please subscribe, like my tutorials, follow me on Twitter, Facebook, and so on, and I hope to show you more cool stuff in the future. Thank you all for watching, goodbye, and see you in the next tutorial. Goodbye.